Alright, Train Circular 9237, Operator Circular Welding Theory and Application, Reporting Errors, Recommendations, Improvement, May 1993, Chapter 10, and then we're on 1014, Submerged Arc Welding. Generally, submerged arc welding is a process in which joining the metals is produced by heating an arc and arcs between the bare metal electrodes and work. The arc shielded by a blanket with a granular fusible material on the arc. Pressure is not used. Filler metal is obtained from the electrode or from a supplementary welding rod. The equipment consists of the required submerged arc welding as shown in Figure 1059. The equipment consists of the welding machine, power source, a wire feeder with a control system, welding torch, automatic welding gun, and welding gun, cable assembly, semi-automatic flux copper feeding machine, usually flux recovery system, travel mechanism, automatic welding. Figure 1059 shows the block diagram of shield metal submerged arc welding, handheld gun or flux hopper, electrode wire feeder direction, travel base, metalwork lead, auto torch, flux, electro lead, control system, and power source. Alright, the power source of the submerged arc welding must be rated with a 100% duty cycle. The since the submerged arc welding operation area are continuous, and the length of the time made in weld may exceed 10 minutes for the 60% duty cycle of the power source review that may be derated according to the duty cycle curve of the 100% operation. When constant current is used with either AC or DC voltage, since the electrode wire feeder must be used with the constant voltage used with a simpler feed fixed speed wire feeder system and used with the constant voltage system is only used with a direct current. Both generator and transformer rectifier power source are used. Both of the rectifier machines are more popular. Welding machine submerged arc welding, but the range is size of 300 amperes to 1500 amperes. May be connected in parallel to provide extra power with a high current application. Direct current power is used with a semi-automatic application. Alternate current power is usually primarily with a machine with the automatic method. Multiple electrode systems require specialized types of circuits, especially with the AC is employed. Semi-automatic welding application welding gun cable assembly is used with a carry electrode and current to provide flux core in the arc of the small flux hopper attached to the end of the cable. Assembly electrode wires fed through the bottom of the flux hopper through the current pickup to the arc of the flux is fed with a hopper to the welding area by means of gravity. The amount of flux fed depends on how high the gun is held above the work. The hopper gun makes an included start switch initiating the weld that may utilize the hot electrode so that when the electrode is touched with the work, the feeding will begin automatically. For automatic welding, the torch is attached with a wire feeder motor and includes the current pickup of the transmitting welding current with the electrode with a wire with the flux hoppers normally attached by to the torch and may have magnetically operated valves which can be opened and closed by the control system. 7. The other pieces of equipment sometimes may include a travel carriage which can be a simple tractor, complex moving specialized fixture with a flux with a recovery unit normally provided to collect the unused submerged arc flux return in the supply hopper. Submerged arc welding system can become complex with incorporated additional devices and seam follower weavers rovers. Advantages. Major advantages of submerged arc welding process are high quality welded metal, extremely high deposition rate and speed, smooth uniform finish weld with no spatter, light or no smoke, no arc flash, thus minimum need for protective clothing, high utilization electrode wire, easy automation for a high operator factor, normally on no involvement of manipulation skills. The submerged arc process widely used with a heavy steel plate with a fabrication work. This includes the welding and structural shape of the longitude, same with a large diameter of the manufactured machine components for all the types of heavy industry manufactured vessels. Tank for pressure for the storage used with widely used with the shipbuilding industry for splicing and fabricating sub-assemblies and maybe other industries over where steel are used in medium and heavy thickness. It's also used for the surfacing, building, workup of the maintenance and repair limitations and process and major limitations. Submerged arc welding is in its limitation of welding position or limitation with the primarily used only with a welded metal with low alloy, high strength, high input with a slow cooling cycle. Can be a problem when welding quenched or tempered steel with a high input with the limitation with the steel with the question must be strictly adhered to when using submerged arc welding. This requires making multiple passes where single weld pass welds would be acceptable in the mild steel. In some cases, the economic advantages may reduce to the point where the flux core arc welding or some other processes should be considered. In semi-automatic submerged arc welding, inability to see the arc and puddle can be disadvantaged with the reaching of the root of the groove weld and properly hitting, filling, or sizing. Principal operation: submerged arc welding process shown in figure 1060 with the utilize with the heat between the continuous fed electrode work and the heat of the arc melts surface of the base metal with the end of the electrode with the balance melted off of the electrode transferred with the arc to the workpiece where it becomes deposited welded metal shield is obtained by the blanket of the granular flux laid directly over the welded area. The flux closes to the arc melts into the intermixing with the molten welded metal, helping purify, fortify the flux form of the glass-like slag with a lighter weight, and then is deposited. While the metal flux or surface of the protective coverage of the weld is submerged under the layer of flux and slag, hence the name submerged arc welding. The flux and slag normally cover the arc so that it is not visible. The unmelted portion of the flux can be reused. The electrode is fed with the arc automatically from a coil. The arc is made automatically. The travel can be manual by machine. Arc is initiated by fuse type start by reversing or retract system. Alright, your normal method of application position capability with the most powerful method of the application machine method. Operators monitor with the welding operation. Second, popularity with the automatic welding. The welding is push button operation. The process can be applied semi-automatically. However, this method of application is not too popular. The process cannot be applied manually because it is impossible for a welder to control an arc that is not visible. The submerged arc welding process, limited position welding process. The welding positions are limited because of the large pool of molten metal within and the slag are very fluid and will tend to run out of the joint. Welds can be done in flat position and horizontal fillet position with ease under special control for the procedure of the possible to weld horizontal position, sometimes called a 3 o'clock weld. Requires special devices to hold the flux up so that the molten slag of the weld cannot run away. The process cannot be used in the vertical overhead position. Metal weldable thick ranges submerged arc welding is used. Weld low, medium carbon steel, low OLA, high strength steel, quenchant tempered steel with many of the stainless steel, but they've been experimentally maybe usually welded certain copper alloys, nickel alloys, even uranium. This information is summarized in table 1021, base metal weldable by submerged arc welding processes. Metal thickness of 1/16 to 1.5 inch can be welded with no edge preparation. Edge preparation, welds can be made with a single pass material with a 1/4 inch to 1 inch. When multiple technique of the maximum thickness of the particularly unlimited, the information is submerged in the table of 1022. The horizontal fillet weld can be made at 3/8 of an inch, and a single pass and flat position fillet welds can be made with a 1 inch size. 1022 shows the base metal thickness. Joint design. Although submerged arc welding process can utilize the same joint design with the shielded metal arc process, the different of the joint details submerged for the maximum utilization efficiency of the submerged arc welding. For groove welds and square groove, the design can be used up to 5/8 of an inch thick. Beyond the thickness of the level, the required open roots are used with the backing bars necessary since the molten metal will run from the joint with a welding thicker metal with a sufficient large root with its use of the backing bar, making it maybe eliminate it. However, to assure the full penetration when welding from one side, backing bars are recommended with both sides are accessible. Backing weld can be made with it while fusing the original welds that provide full penetration. Recommended submerged arc joint designs are shown in figure 1061, page 1088. Alright, your welding circuit. In current, the welding circuit employed with a single electrode submerged arc welding is shown in figure 1059, page 1083. The process requires a wire feed, similar and a power supply. The submerged arc welding process used with either direct or alternating current with the welding power. The direct current used with the most applications used with a single arc. Both direct electrode positive and electrode negative are used. Constant voltage type of the direct current power is more power. Submerged arc welding with 1/8 of an inch and smaller diameter electrode negative. The constant current power system is normally used with welding with 5.3 to 5/3 2 inches large diameter electrode wire. The control circuit of the constant current power is more complex. It attempts to duplicate the actions of the welder to retain specific arc length with the wire feed system. Must sense the voltage across the arc and feed the electrode wire into the arc to maintain the voltage. As the condition change of the wire feed must slow down or speed up, maintain a prefixed voltage across the arc. This adds complexity to the control system. The system cannot react instantaneously. The arc starting is more complicated with the constant current system since it requires the use of the reversing system to strike the arc and retract and maintain preset at a voltage. And this shows welding joint design, submerged arc welding sheet. You have your butt backing, closed with a bevel, square grooves, steel backing, square groove with both sides, square single and V grooves, welded both sides, single groove welded from one side of the steel backing, double V grooves, both sides, double B groove welds both sides, single U grooves welded from both sides. Alright, for arcing welding, the constant current power is always used with a multiple electrode wire system with both AC and DC with a constant current power system used with a constant voltage system. However, the can be applied with the two wires are fed with the arc is applied with a single power source with the welding current of submerged arc welding and vary from as low as 50 amperes to as high as 2,000 amperes. The most submerged arc welding is done with a range of 200 to 1,200 amperes. Deposition rates and weld quality. The deposition rate of the submerged arc welding process is higher than any of the other arc welding processes. The deposition rates of the single electrode are shown in Figure 10.26. This is at least four related factors for the control of the deposition rate of the submerged arc welding: polarity, long stick out, additives in the flux electrode, additional electrode, the deposition rate of the highest direct current electrode. Negative, the deposition rate of the alternating current is between the direct current electrode, positive and negative. Polarity of the maximum heat is the negative pole. The deposition rate with any welding current can be increased with extending it into the stick out. The distance of the point where the current is introduced into the electrode arc, where using a long stick out, the amount of the penetration is reduced. The deposition rate with increase with the metal additive of the submerged arc flux. Additional electrodes can be used to increase the overall deposition rates. The quality of the weld metal of the deposit of the submerged arc welding process is high, with the weld strength with the ductility extends with the mild steel low alloy base metal. Material with the correct combination of electrode wire and submerged arc flux is used when submerged arc welds are made by machine or automatically. The human factor inherent with the manual welding process is eliminated. The weld will be more uniform, free of inconsistency. In general, the weld bead size of the per pass is much greater with the submerged arc welding than any of the other arc welding process. The heat input higher, the cooling rates are slower. For this reason, the gases allow the time to escape. Additional, since submerged arc slag is lower density of the welded material, it will flow out of the top of the weld uniformly. The consistency and advantages of the process when applied automatically. Several problems may occur with the semi-automatic application. The mouth of the electrode wire may be covered with the leaf of the nozzle with the welding with the gun with the curvature of the cowl of the arc to be struck out with location not expected by the welder. Welding fairly deep of the groove with the curvature with the main cowl of the arc to gain one side of the weld rather than one root. This will cause incomplete root fusion. Flux will be tapped at the root of the weld. Another problem with semi-automatic is that the complete filing of the welded groove will maintain exact size. Since the weld is hidden and cannot be observed while it is being made, this requires making extra passes. This, in some cases, too much of the weld, the deposit variation of the root opening effect with the travel speed. The travel speed is uniform. The weld may be under or overfilled with a different area. The high operator skill will overcome this problem. This is another quality problem. There's another quality problem with extremely large single path of the weld deposit with the large weld solidified with impurities into the melted base metal, and with the weld metal all collect the last point to freeze, which can center line with the weld. If there's sufficient restraint and enough of the impurities are collected into this point, with the center line cracking may occur. But this can be happening with making a large single pass. The flat fillet welds in a base metal plates are 45 degrees from flat. Simple solutions is to avoid placing the parts at true 45-degree angle. This should be varied approximately 10 degrees, so the place of the root of the joint is not in line with the center line with the fillet weld. Another solution is to make the multiple pass rather than attempting to make a large weld in single pass. Another quality problem has to do with hardness and deposit of the weld of the deposit of welded metal. Extremely hard welded deposits contribute to the cracking in the weld during fabrication during service. Maximum hardness level of 225 brittle isn't recommended for the reason the hard weld of the carbon and low alloy steel is too rapid cooling with the inadequate post-welded treatment. Excessive alloy pickup of the weld and metal. Excessive alloy pickup of the ooze selecting with the electrode has to do with much alloy selecting flux that introduces too much alloy into the weld, or the use of excessive high welding voltage. In automatic machine welding, the defects may occur at the start. At the end of the weld, the best solution is to run out the tabs so that starts or stops will be on the tabs rather than on the product. Your weld schedule submerged arc welding process applied by the machine. Fully automatic should be done according to the welding procedure schedules, table 1023, page 1093, and figure 1062, 1092. Show the recommended welding schedule for the submerged arc welding single electrode with mild low alloy steel with a table that can be used with welding any other ferrous metals whether developed from a mild steel. All of the welds may be produced by this procedure should be qualification of the test assuming the correct electrode flux have been selected. If the schedules are varied more than 10%, the qualification of the test should be performed to determine the weld quality. It shows submerged arc welding square groove, V groove, T groove, fillet, V groove, square groove, V groove, double V groove, welding current table 2, and then over here, if you flipped it, it would be welding procedure schedule for the submerged arc welding, and then that goes on for another page. Alright, your welding variable. The welding variable for the submerged arc welding are similar to the other welding process for the several exemptions. The submerged arc welding electrode type of the flux type is usually based on the mechanical properties required by the weld of the electrode with the flux combination based on the table 2024 of the page 10.103. To match with the metal being welded, the electrode side of the rated with the welded joint side of the current with the recommended with the particular joint that must be considered to determine the number that passes the beads for a particular joint. Welds of the same joint with the dimensions can be made, and many of the few passes depending on the welded metallurgy desired. Multiple passes usually deposit the higher quality welded metal polarity is established initially based on whether the maximum penetration, maximum deposit rate is required. The major variables of the effect of the weld that involved with the heat input include the welding current, arc voltage, travel speed. Welding current is most important. The single pass weld of the current should be sufficient for the desired penetration without burn through. The higher the current, the deeper the penetration. The multiple pass weld of the current is suitable for the produce the size of the weld except for each of the path. The welding current should be selected based on the electrode side of the higher welding current, the greater the melt-off rate, the deposition rate. The arc voltage will vary with the narrow limits of the welding current, with the influence of the bead, with its shape. The higher voltage will cover the bead, with the wider, with the flatter, with the extreme high arc voltage should be avoided. Since in this case of the cracking, this is because of the amount of the flux has melted. Excessive deoxidizers may be transferred to the welded deposit, lowering the ductility of the higher arc voltage or increase the amount of flux consumed. Low arc voltage produces the stiffer, but improve the penetration, particularly over the bottom of the deep grooves. If the voltage is too low with a very narrow bead, will result it will have the high crown and slag, which will be difficult to remove. Travel speed influences both bead with the net penetration with the fast travel speed produced with the narrow beads and less penetration. This can be an advantage for the sheet metal with the welding with the sheet beads. A minimum penetration are required. If speed is too fast, however, the tendency of the undercut and porosity since the weld freezes quicker. If the travel speed is too slow, the electrode stays in the weld puddle too long. The creates a poor bead shape and may excessive the spare flash of the layer of flux. Her secondary variables include angle of the electrode work, the angle of the work itself, the thickness of the flux core, the distance between the current pickup of the tip and the arc, and the latter factor called the electrode stick-out has been considerably effective on the weld. Normally, the distance between the contact tip and the work of the 1 and 1.5 inch of the stick-out is increased beyond the amount that will cause preheating of the electrode wire, which will greatly increase the deposition rate of the stick-out, increase the penetration into the base metal. The decrease of the factor must be given serious consideration because of some of the situation penetration is required for the relationship between the stick-out deposition rate shown in figure 1064. 1064 shows the stick-out versus deposition rate, amperes, pounds per inch, and kilograms per hour. 3.25 inch stick-out, 1 inch stick-out. Depth of the flux core must be considered whether thin, whether the too much arc through the flux or the arc flashes. This may often cause purity with the flux porosity. The flux depth too heavy with the weld may be narrow and humped to many small particles of the fluxing surface. Pitting since the gases generated, the weld may not be allowed to escape. This is sometimes called a peck mark on the bead surface. One of the more tips for the using process. One more application of submerged arc welding is on a circular weld with the parts of the rotated with the bead on the fixed head. The welds can be made with the inside with the outside diameter of the submerged arc welding. Proceed with a large molten weld puddle, molten slag, which tends around with the dictate with the outside of the diameter of the electrode should be positioned with the head with the extreme top of the door 12 o'clock position, so that the weld will begin solidified before it starts on the downside slope. This will become more problem with the diameter of the start of the With the part being welded, it gets smaller. Improper electrode position will increase the possibility of the slag entrapment on the poor weld surface. Angle of the electrode should also be changed with the pointing with the direction of the rotating part. When the welding is done with the inside of the circumference, the electrode should be angled so that it's ahead of the bottom center or 6 o'clock position. Figure 655 illustrates these two conditions. 655 shows the welding rotating circuit parts, off-center welding arc, rotation, outside diameter, off-center welding electrode, rotation, inside diameter. Sometimes the work bead welded is sloped downhill or uphill to provide different types of weld. The bead contour of the work is sloped downhill, the bead will have the bead less penetration and will be wider. If the weld is sloped uphill, the bead will deeper penetration will be narrower than based on all the other factors remaining the same. The information in figure 1066. Angle of slope of the work, electrode travels downhill, uphill, and then level. The submerged arc welding continues. This weld with a different developing the angle of the electrode with the respect of the work is level to travel the angle, which can be drag or push angle, has a different definite effect with the bead contour weld metal with penetration. Figure 1067 shows the relationship. 1067 shows the angle electric versus the electrode pushing angle with the cross section of the electrode travel the pulling angle of the cross section. One side with a complete root with the penetration can be obtained with a submerged arc weld with a welded joint with a design with a tight root opening, fairly large root face with a high current electrode positive should be used with a joint with a design root opening minimum a root face if necessary, using backing bar with something as if there's nothing to support the molten weld of the metal with the molten flux for the use of the very fluid will run through the narrow openings. If then this happens, the weld metal will fill. Follow the weld will burn through from the joint with the backing bars needed with whether there is root opening the minimum for a root face. Your copper backing bars are useful with welding thin steel. The backing bars would tend to melt through the welded metal, fall away from the joint with the backing bar to hold the welded metal into place for the solidify with the copper backing bars may be water cooled to avoid possibility of the melting copper pickup of the welded metal, but the thicker metals of the backing may be submerged in flux cores of specialized type flux. Variation of this process, a large number of the variation processes give the submerged arc welding additional capabilities. Some of the more popular variations are 2-wire system and same power source, 2-wire system separate power source, 3-wire power system separate power source, strip electrode for surfacing, iron power in addition to the flux, long stick out welding electrode, cold filler wire. Alright, here the multiple wire system advantages since the deposition rate travel speed can be improved by using more electrodes. Figure 1068 shows the two method utilizing 2 electrodes with using a single power source, one of the 2 power sources with a single power source used with the same drive rules are used to feed both electrodes into the weld of the 2 power sources are used. The individual wire speeds must be used to provide electrical insulation between 2 electrodes with the 2 electrodes separate power. It is possible to utilize with a different polarity of the 2 electrodes utilizing alternate current on one of the direct current on the other. Electrodes can be placed side by side, and this is called transversal electrode positioning, and this can be placed on the front of the other tandem electrode position, electrode travel, power source, transversal electrode position, tandem electrode travel position, power source. The 2-wire tandem electrode power source, the individual power source with the using wire extreme position is required. The leading electrode is positive, with the trailing electrode is negative. The first electrode creates a digging action into the second electrode filled with the welded joint. When 2 DC arcs are in close proximity, the tendency of the arc interference between them. In some cases, the second electrode is connected with the alternate current to avoid interacting with the arc. Alright, the 3-wire tandem system normally use the AC power with the 3 electrode connect with the 3-phase system. The systems are used for the making with a high-speed longitudinal system, a large diameter pipe or fabricated beams, extremely high current that may be used corresponding with a high-speed travel to deposition rates. Strip welding system is usually overlaid with a metal with alloy steels, usually with a stainless steel with a wide bead with a produce with a uniform minimum penetration process. Variation shown figure 1069 is usually overlaying on the inside of the vessel, provided with a corrosion resistant stainless with a steel with utilizing strength with the economy of the low alloy steel for the wall thickness and single electrode feeder with the required with a special flux. Normally use the width of the strip over 2 inches. A magnetic arc oscillation device is used to provide even burn off of the strip of the uniform. So 1069 shows a strip electrode of surface for the power source strip drive rolls, electrode treble flux hopper cladding flux and flux core. Another way of increasing the deposition rate of submerged arc welding is to add iron base ingredients of the joint under the flux. The iron in this material that will melt into the heat of the arc and will parts of the deposited welded metal. The increase of the deposition rate will increase welding properties of the metal. Additives can be used in special surfacing application. The variation can be used in single wire, multi-wire installation. In Figure 1070, Shins shows the increased deposition rate attainable. So 1070 shows your welding iron power additives. Alright, another variation is the use of electrical cold wire fire filler wire fed into the air with a cold filler wire. Can be solid flux core to add special alloy for the welded metal, regulating addition proper material. Property of the deposit of the welded metal can be improved with the possible of utilizing flux core wire of the electrode one multiple electrodes to introduce special alloy of the welded deposit metal. Each variation requires special engineering to ensure the proper materials added to provide the desired deposit properties. Type of application submerged arc welding process is widely used in the manufacture of most heavy steel products, including pressure vessels, boiler tank, nuclear reactors, chemical vessels, etc., and other use of the fabrication trestles of the beams used to weld flanges into the web. Heavy equipment industries is major use of the submerged arc welding. Materials used are used in submerged arc welding flux and consumable electrode wire. A submerged arc welding flux shield from the arc of the molten welded metal from the harmful effect of the atmospheric oxygen and nitrogen flux contained with the deoxide scavenger will help to remove impurities of the molten welded metal. The flux to provide with the means of introducing alloy of the welded metal. As the molten flux cools the glass slags, they form as a covering that protects the surface of the weld on the melted portion of flux does not change its form. Its properties are not affected, so it can be recovered or reused. The flux that does melt form in the slag covering must be removed with a weld bead. This is easily done after the weld has cooled. In many cases, the slag will actually peel without requiring special effort. The removal of the groove welds or solidified slag may have removed by a chipping hammer. Alright, fluxes are desired with a special application. The specific type of the welded deposit submerged arc flux can be different with the particle size. Of many of the flux are not marked from the size particles because of the size of the design and produced with the intended application. There is no specific submerged arc flux with a Northern American or method of classifying flux. However, the means of the deposit weld of the metals by various combinations of electrode proprietary submerged arc welding flux is covered with American welding standard, bare carbon steel electrodes, and fluxes submerged arc welding. In many cases, in this way, the flux can be designated to be used with different electrodes to provide a deposit welded metal. Analysis is desired. Table 1024 shows the flux where with a combination of the mechanical properties the deposit welded metal. Section 3, related processes. Testing.